So, number one, is just look at the graph, right? What's the amplitude? Unit. What's the period? 5.8. And we already have the unit seconds. I gave you half a period. It's marked up there, right? You need to double that to get your actual period. What equation do we want to use to find the max velocity? Yeah, Vmax, or V naught, sometimes you see, equals omega x naught. Okay, Vmax equals omega x naught. Now, V does not equal omega x. Do not get those two backwards. Do not try to switch that in. This is the one equation that works for maximum velocity. Okay. If you have trouble remembering this, because this is not in your equation sheet, and it's very, very useful, you can use the equation V equals plus or minus omega square root of x naught squared minus x squared to derive back around to it. Right? What position x is velocity maximum? Zero. Right? At equilibrium. Whenever it's accelerated all the way back down to the 0 point. So if this becomes 0, I get V equals omega square root of x naught squared, and then that kind of explains itself, right? So this is V naught or V max equals that. Okay? So what did you come out with here for V max? Maybe we need to go through this. Maybe this requires a few other steps because we didn't talk about omega, right? So that's going to be, how do I get omega? 2 pi over period. Good. 2 pi divided by 5.8 times x naught, 3.5, equals maximum velocity, which is what? 3.8 meters per second. Right? Sorry. Okay. Negative. Good. Max acceleration. This equation also is not your packet, nor is there really a way to derive around to it. I guess you can try to figure out a way. But this is something you have to have memorized. It is the defining equation for simple harmonic motion. Specifically, you got to be able to talk about the negative out in front. They're going to ask a question about that, or at least I am on the test. What equation am I talking about? Yeah. And that's the acceleration at any point. Now, at what location is A at a maximum? At the end, right? So I'm going to use naughts here for maximum again. A naught, x naught, right? Maximums. We already have omega. We have x naught, right? So this becomes negative 2 pi over 5.8 squared times 3.5. So what's that work out to? What is the maximum acceleration, please? Thanks. Negative 4.1 meters per second squared. You can say positive 4.1 just to make both directions. Right? But we use a positive amplitude, that's why negative acceleration. In fact, we have a positive amplitude and negative acceleration. Why do those two things have to go together? Good. The acceleration is always the opposite direction from displacement. Let's always trying to bring it back to equilibrium. So if I have a positive, if I use the positive amplitude, you will get a negative acceleration at all times. Now this last one. The velocity at, no, as long as you indicate, if you put in positive 3.5, you have a negative 4.4, or you have put a positive 3.5 and you have a positive 4.1 coming out, I'd take off. Right? You use the positive amplitude, and you cannot put something that you shouldn't. Now, it's positive here. You cannot just look at the graph to get it. What equation do I need to use? V equals what? Yeah, that's good. That's the, ladies and gentlemen. That's the equation you find, Emily, in your packet. That's the equation you find in your packet. And we already know what Vmax is. By the way, if you didn't know what Vmax was, you can substitute in here omega x naught for V naught. Okay? Why do we use the cosine one there? Because this was a sine graph. We use its partner right below it in our sheet for velocity. It comes from taking the derivative. You have to use his partner. Look at your equation sheet, look one down. Okay? And then this just becomes plug chug from there. V equals, we found V max to be 3.8. Cosine, we know what omega is now. It's 2 pi divided by 5.8 times t, 3.39 seconds, 3.93, excuse me. Right, and that's going to allow me to calculate the velocity. Is that not bad? The rest of you? 3.78, 3.79, 3.7, negative what? 1.7. Negative 1.05, that one. It's a good discussion. Now, negative. The reason why a negative number here, the cosine's coming out from negative something. If you think about the graph, right? In fact, let's scroll back up. At 3.9 seconds, right? 3.93 seconds. Where are we? Well, we said right here is what again? 5.8. What's this down here going to be? What time is that going to be? It's halfway between 2.9 and 5.8. So you're looking at a location of 3.9 somewhere in here, right? Which way is this object going? More negative or back to the positive? It's still going down. It's still going in the negative direction, which means the cosine there, it should give us a velocity that is in the negative direction. See what I'm saying graphically? So your calculator, whenever you plug in cosine of 2 pi divided by 5.8 times your 3.93, right? This cosine part right here, right? All this guy should be what comes out to give you the negative, then times the maximum velocity, 3.8. Okay. The cosine part should give you a negative decimal number too. Should give you a negative decimal number too. That's why it will always come out less than your 3.8. Okay. Cosine of something will never be greater than 1. Never ever. Right? Good. Good. Yeah. Yes. Yes. You can do these in radians or degrees. We just prefer radians here. Right? Okay.